Hey, we are live. Is everybody ready?
Ready.
It's cool. It's plural. People are like, who's this? Who's coming? What's happening? Ha! Hello, hello, hello. Welcome, everybody. Welcome to Year of the Voice, Chapter 4 today. Let's do a quick introduction round and then we get started because it is a super exciting thing. We have so many cool stuff that we've built, not only us today, we are also joined by David. But let me first just start by introducing myself. I'm Paulus. I am the founder of Home Assistant. And, I'm involved with voice and doing a bunch of cool stuff and here and there.
Yeah, so I'm Mike Hansen. I'm the voice guy at Nabukasa, also doing voice, coincidentally. And yeah, I'm the founder of Raspy, a open source voice assistant toolkit.
And hi, I'm David Skripka. So I'm not with Home Assistant, but I'm the developer of Open Wakeword, which is a library we'll be talking about a lot during the stream.
Oh, man, spoilers.
Oops. Oh.
All right, so let's get started. Yeah, I want to start by just reiterating what we're doing. Why Year of the Voice? What is Year of the Voice? At the end of last year, we decided that in 2023, with Home Assistant, we want to build a voice assistant. And more explicit, the goal had to be we want to let users control Home Assistant by speaking in their own language. So, what does that mean? It means that a person from Germany should be able to speak German, a person that wants to speak Polish should be able to speak Polish to their house. And to achieve that goal, we hired Mike. Mike was already doing a lot of voice stuff. He's working full time on this year. He is not doing this alone. He is leading a whole community. We've built a whole voice assistant community up, of which we're also gonna talk about. And yeah, and it's been going great. So today, chapter 4 already. I mean, we're into October, so we had to deliver, right? Like otherwise, it wouldn't be a year, but a decade or whatever. So yeah, let's see what we've done so far.
Yeah, so we've had 3 chapters so far. In the first chapter, we started off focusing on text. So this was where you could type a text command to Home Assistant in your native language and have it recognize what's called an intent and then execute that intent. Something like turn on the lights or set the kitchen light to red or something. We started off with just a handful of languages, and as of today, we're up to 56 languages in our repo. This is a community, effort by and large. We have 188 contributors, and this is something where we're slowly building up to the 67 languages Home Assistant supports? So around
76.
76. Okay, so we're making our way towards that, and we love contributions here, and I'm hoping, at the end of the year here, we'll get back and try and clean up a lot of stuff and make this much better. So in chapter 2, we got into audio. This is where we added speech to text and text to speech into what's called a pipeline. So you could create a full voice assistant in Home Assistant. And we introduced a number of options for using this, including the M5 Stack Atom Echo. That's this tiny little device, plugs into a USB-C cable, has a mic and speaker built in, and only $13, so not bad. And actually in stock, which is great. So we demonstrated that and using an analog phone for the world's most private voice assistant. This was where you could pick up the phone, talk to your smart home, have a conversation, put the phone down when you're done, and it works through voice over IP. And so for the audio, there are a number of options. We have a cloud option through Home Assistant Cloud. This is super fast and it has many, many different languages. See 130 languages for speech to text, text to speech, all sorts of different dialects. So yeah, it's a great option for the cloud. And then there are also local options. We have Whisper for speech to text, and then Piper, which is the text to speech system I wrote that now supports 30 languages and over 100 voices. And some of these come from the Home Assistant community. So as of today, we have 17 voice data sets from volunteers that have been completed. This has added new languages like Hungarian, Romanian, and others that we just didn't have before because there wasn't open source data for this. So this is an awesome contribution from our community. And then lastly, chapter 3, we added native Android support, which is awesome. So you could, on your phone, on the Home Assistant app, just push the button, speak your voice command, and then also on the watch, you could set Home Assistant as your default digital assistant. So you could just hold a button, say your voice command, and have it work like that. And that was where we've been.
Right. So before we dive into all the stuff of chapter 4, I quickly want to talk about, like, I already mentioned Mike is working on this full time. I'm working on this full time. Like, how does it work? Like, how can we build all this cool stuff, publish it as open source, anyone can use it for free? It is because of Nabukasa. So Home Assistant, I founded it 10 years ago. Nabukasa is a company that I founded 5 years ago. Nabukasa offers Home Assistant Cloud, which is a service that enhances your Home Assistant instance. We don't run your Home Assistant in the cloud, but instead you get access to an end-to-end encrypted remote connection. You get access to speech-to-text, text-to-speech, like Mike said, 130 different languages and dialects, super fast. You get access to integrate with Google and Amazon. And the revenue we gather with this cloud subscription is being used to hire people to work full-time on running the Home Assistant project. And the Home Assistant project was last year. We were the second most active project on GitHub. Like, there's a lot to do. And so we are doing, the masses of chores, right? Like anything that just needs to be done just because such a big organization and system needs to keep moving. That's the kind of stuff we do. And of course, we build also foundations, like, for example, Voice, where we build the infrastructure, we build the building blocks, and then together with the community, we kind of fill in the missing blanks. So Mike mentioned already, like Hungarian, there was not a good public data set. Well, actually with Nabukasa, we hired a studio and a Hungarian person recorded their voice, and now we have all access to text-to-speech Hungarian voices, right? So this is the kind of stuff where constantly with Nabukasa, we are investing in Home Assistant, making sure it is and remains the best open source home automation project. And we don't just invest in Home Assistant, but also the ecosystem around it. We call it the open home, like we run ESP Home as well. Things like Piper, for example. And, these things, we don't like vendor lock-in technology. Piper is being used today for like screen readers, for example. And there were some other use cases that it was unlocking. So lots of cool technology being built, lots of benefit for everyone. All because like people like you are subscribing to Home Assistant Cloud and helping us achieve this.
I'll make a note too. So the voice data sets that we fund to have recorded are also made public domain. So this is something that benefits Piper as well as other text-to-speech systems now and in the future.
Yeah. We don't like locking people in. Like, we spend money to like help somebody record something. Like, please let everybody like benefit from this. Okay, so we started with chapter 1 in January. And since January, people have been asking us, okay, where is wake word? Why is there no wake word? And for the people that are not fully familiar with all the terminology in the voice assistant world, a wake word is the word that you say to activate a voice assistant. So, for example, okay, Google, Alexa, those are wake words that will trigger a voice assistant. And if you have one in your room, you'll probably be annoyed now because they are starting to listen for commands, and then the command is being executed. Now, voice satellites, like the small devices that generally are listening for the wake word, they're very low powered. And because they're low powered, it starts to actually become very complicated, because now wake word detection is based on AI. It's a very complicated model. It takes a lot of expertise to get that going. And to get an AI model to run on a small compute platform like an ESP Home and ESP32 device, it requires a whole different set of expertise, right? Like, David, we're going to talk with him a lot today about like wake words. Like, David can do wake word technology. He cannot take a wake word model and run it on a piece of hardware. It also means that your piece of hardware, that's then one piece of hardware that's supported, and it means that like it doesn't just translate to the next piece of hardware, right? So for every microcontroller, for every model, we would have to sit down and like find an expert that really wants to help us run this model on this platform. And we felt that this is not a good foundation for Home Assistant to build upon, because we want people to experiment, right? Home Assistant is the platform to like rapidly prototype new stuff and like try it out. And of course, the winners kind of like of the easiest to use technology, they bubble up, and like that is what the more less advanced user will work with. But like we need to be able to have anyone run anything, right? Like choice is very important to us. So doing wake word detection in ESP Home is really hard. And it's a pity because the other two parts, capture audio and process audio, we actually had already solved. I don't know if you remember in chapter 2, we announced that the M5 Stack Atom Echo smart speaker development kit is a long name, but this device, we added assist support to ESP Home. And so with this device, you could actually, by pressing the button and you start speaking, you could control Home Assistant. So we had everything back then except for wake word. So, and this was really, really fast. In fact, like, Mike, you want to show it?
Yeah, sure.
I'm adding your...
Okay, yeah. So I got the M5 Atom Echo here, and I got this light bulb hanging behind me for the demo. Super high tech here. So what you could do is there's a little button. Oh, there we go.
Yeah.
Yeah, so there's a little button on here. You can just push it, and you can speak your voice command. So I could do something like push it and turn on a hanging light.
Boom.
All right, so we can do stuff like that. I can do set hanging light to red. Okay, and it talks back to you. The speaker's a little small.
Yeah, and this thing is fast, right?
Yeah.
Like fast. You can see, like, we press the button, we speak, boom, it's executed. There's hardly any delay. There's no by the ways, no upsell for ads. Like, this is the Home Assistant experience like we wanted. But no wait yet until
well, I didn't notice this switch before. If only it was there before. So let me flip this switch. Now you can see, maybe you can see it's a little purple in there. So now let me try this again. Okay, Nabu, set hanging light to blue. Oh, boom. And here, I'm going to put this on my desk. Step away for a moment. You can see I'm Halloween themed already.
Oh, you're wearing pants. That's good.
Okay, Nabu. Set hanging light to green.
Nice. All right.
And there we go.
Wake words.
Across the room.
Yeah.
This little thing.
So this is awesome. This is really, really, really great. Let me just change back to my slide chat because, yeah, we have to update this slide from chapter 2 because now for $13.50 you can install ESP Home on it directly from your browser, and you can turn this little device into a voice assistant for Home Assistant. We had a tutorial on Home Assistant.io how to do this. The part to buy that has been updated, probably not right now, but after the stream will be updated, and you can actually get started with this today. All the wake word stuff has been released in the last 2 releases of Home Assistant. All the add-ons, there's been a bunch of bug fixes. So if you've installed before, please update to get the latest and greatest experience.
And now we could talk a little bit about how is this working after what we just said about how wake word is so hard. Well, so we moved the problem somewhere else. So rather than try and get something running on this tiny little thing, which has just a ESP32, not even NS3 or anything, what we decided to do is, okay, let's do wake word detection inside Home Assistant itself, right? You're already running a local Home Assistant server that's got more power certainly than an ESP32, probably a Raspberry Pi 4 or better. And so what we instead do is stream audio over and do wake word detection inside Home Assistant. Now, this has a number of benefits and a couple downsides that we'll talk about. The benefits are that, which is awesome, anything that streams audio can be a voice satellite, right? So it could be something like this, even something lower powered, as long as it can connect over Wi-Fi and push UDP packets, really. If it can run ESP Home, it can immediately become one. So you can run wake word models on more powerful machines like the Raspberry Pi 4, and through the protocol we have, you can actually run different pieces like the wake word detection even on a more powerful server yet. So you don't have to run it right with Home Assistant. It can be external. Also, it makes it easy to experiment and develop these new models. So this is a kind of an underrated thing about this. Rather than having a wake word model that has to be tailor-made for every board, we can run a full-strength TensorFlow Lite, or PyTorch model in Home Assistant, which is where everybody is experimenting with these models, right? So this means that you can go straight from, I built a new wake word system, to I'm running it in Home Assistant as part of a real pipeline, in a day. Now, of course, there's always downsides to things. The downside is you're streaming audio into into Home Assistant. Each satellite requires ongoing resources. We've tried to mitigate this with something called voice activity detection, which is working okay on this, not so great. We can improve that, but that just means that there's enough power in these things to look for voice in the audio it's locally, right? And so if there's silence, it'll just not stream anything. But if somebody starts speaking, then it starts streaming, and that needs resources in Home Assistant. And of course, the audio quality from different devices varies wildly, right? So we've tried to mitigate this by having post-processing of audio inside Home Assistant. We do noise suppression and auto gain and some amplification. And so that's how this tiny little mic is able to hear me across the room, is because I have the settings in ESP Home to amplify that audio before it gets sent through the wake word detection and speech to text.
Because I mean that's the wild part, right? Like this is just one microphone, no fancy audio algorithms, just basic ones, and yeah, your whole room is covered, right? So like, you put this in your office, you can control anything, anywhere.
Yeah. Now we're not doing things like more advanced things like echo cancellation or blind source separation. So if you have, the TV on or music playing, you may find it's more difficult for the wake word recognition to happen. This isn't Alexa. We don't have the resources of $1 billion company, but this is pretty damn cool for $13, I'll say.
Right. But we do, background noise is being taken into account, and I think actually that is a nice little bridge to David.
Yes.
Oh, actually no, we have. Sorry, David. I thought this was the open wake word slide. I'm sorry. I'm gonna quickly do this slide. We now have our voice assistant in the Home Assistant is built out of 4 different parts: wake words, speech to text, conversation, and text to speech. Conversation, that's the one that needs some explanation. That's the one that takes a text of something that has been said and executes it, right, and does something with it and generates a response, which is also text. And then, of course, that response has to be turned into speech because we're making a voice assistant and not a chat box. Now, because we are all about choice today with wake word, where we are focusing mainly our built-in wake words around open wake word, and we'll get to why in a bit. But we also are including Porcupine, which is an older closed source wake word engine that, because it was closed source, it was never going to run on an ESP controller, but because of the way we run it inside Home Assistant, that is not a problem. So we'll get why that has some benefits as well to, for example, use Porcupine. Now, of course, popular options for speech to text, text to speech are for Home Assistant Cloud subscribers. They don't have to do anything. They have access to super fast Azure-powered neural network speech to text, text to speech. If you want to go local, we have OpenAI's Whisper. It runs on a Raspberry Pi, not as fast. You probably want to run a bit more powerful server that you can run also the more powerful models. Downside here is that it has, it works proper for English, but other languages, the failure rate starts to increase. And text to speech, of course, we have our own Piper. We talked about it already. Super fast text to speech. It's really cool. And I skipped over ChatGPT. We have ChatGPT as a conversation agent. It's there. The reason I'm kind of shrugging is because it doesn't hook into Home Assistant. So it is great to talk to, and it will just make up replies. You can tell it hey, you're Super Mario. You can have a conversation about saving the princess, but it won't turn on your light bulbs. So it's a popular option because it's fun for kids. It is not a very useful option.
My kids used it to talk to Santa, so it was fun.
There you go. So wake words. Now is the time, David.
Time to shine.
Open wake word. Tell us what you've built, why you've built it, the technology, why it's the best thing in the whole wide world, and why everyone should use it today.
All right. Thanks, Carlos. So yeah, Open Wake Word. This is a library I've been developing for quite some time now, but I officially released it earlier this year and actively developing it since then. And like I'm sure many of you, I've been interested in this space for a while. I like doing home automation, but I was frustrated. There weren't open source libraries that did wake word detection well. You either had to pay, the hardware was a real problem. Just managing it was real frustrating. So I had done some testing. I have some experience with machine learning, and I thought, hey, I think I can try to produce something that's going to be better, that will meet some of these goals that I think we as a community have. So there were three main things I wanted to do. One, it had to be accurate, right? It had to work well. It needs to pick up the word when you say it and not pick it up when you're not saying it. And I think we've done that pretty well with Open Wake Word. There's some caveats, of course, but the accuracy is really nice. And I'm sure Paulus and Mike can talk more about that later. I wanted this to run on commodity hardware, right? As Paulus is talking about, running it on the edge is a different question. We're still working on that, but this is not a super heavy model. You could run it on a Raspberry Pi 3, for example, very lightweight, and this can work with any type of microphone that you happen to have. So it's easy to get started. And then I wanted to make it easily extensible, right? This is open source software. So I wanted to be able to do things like running multiple wake words at once, training custom models, and even doing things like adapting a model to your voice or your family's voice, things that are much harder to do if you're using commercial software, or you have to be locked into some ecosystem to do that effectively. So these are the goals of what I'm trying to do with Open Wake Word. Already making good progress on a lot of these, and I hope we can continue making progress. All right, so how does Open Wake Word work? It really comes in four different pieces. And the first and probably the most important piece is we are using a model from Google. They trained a really nice audio embedding model, fully open source, so we don't have to worry about anything there, which is, we're thankful for them for doing that. But they trained a really nice model on hundreds of millions of clips from a bunch of different audio sources, and produced something that can really capture the details of what is being spoken or what is being heard in that room. And then we go to this question of, well, how do we get the training data for the wake word in particular? And this is where I really wanted to focus on using synthetic speech. If you have to collect 1,000 examples or even 100 examples of your own voice to get a wake word working, that's a real barrier. And so I wanted to see, could I get this to work with just synthetic data? And leveraging a bunch of different technology, including Piper that Mike has been working on, we can do that now. We can generate thousands, tens of thousands of realistic clips of the target wake word. And then we combine that with techniques that will make this data sound real. Like Paulus was talking about, and even Mike was showing earlier, this has to work across the room, and there has to be echo, and there has to be background noise. And we can do all that. We can add that in, augment the data, and create a realistic data set so that when you actually deploy these models in your home where this kind of stuff is present, it can still work. Not in every scenario, and we'll talk more about that later, but it is robust, right? It won't trigger when your air conditioner turns on, and if you have a fan on, it'll still pick up your voice. And then the last stage is train this at scale, right? Kind of extending what Google already did when they trained this foundation model. Let's take all these approaches. Let's bring in tens of thousands of hours of other data to make sure that we can hit those real world accuracy targets, meaning it activates when you want it to, and it doesn't activate, when you're listening to a podcast or the TV's on in the background.
So there's a comment over here by Dennis asking, how does Open Wake Word compare to Mycroft Precise? I actually want to make a comment about that because I used to work at Mycroft, and Precise is based on a simple neural network as well. But performance-wise, I remember having difficulties. We'd have our devices sitting there with Precise running, and it was listening for, hey, Mycroft is the wake word, and we'd have false activations during meetings all the time. That was a very common occurrence. And I contrast that with the Open Wake Word model that I'm running through this, or I've run it through a couple of other things. I've had it running for weeks. I have actually never had a false positive yet. I've had plenty of false negatives where it didn't quite hear me and I have to speak up or something. But I thankfully have never had a false positive. So for me, that's a major difference in these two. And whether that's I think it's largely the Google speech embedding model that's helping out there, because there's a lot of work that's been done, but also just the augmentation that David has put in this is excellent.
Yeah. I think another thing that's interesting is that why do we rely on a model by Google and not like, built from scratch? And it is the different problems that you can solve with AI. And like Piper, we built it, right? Like, but with Piper, we're only having to regenerate one voice. Like we actually need a single person to generate like 3 hours of data, and we are able to generate a voice. But doing speech to text and understanding voice, you need the opposite. You need not one speaker, you need like basically an infinite amount, like millions and millions of data, different people, different like everything. And so that is something that we cannot do as open source. I mean, I know that like Mozilla has been trying it with deep speech and they have an okay collection, but compared to what Google has access to or what Facebook has access to, we do not have such scale, right? So we're very, very happy that we're able to run this model by Google, but it was also another bottleneck why we couldn't just drop this on a microcontroller, because this model wasn't meant for microcontrollers. So, Dave, you want to say anything else about architecture, or should we go to the next part?
I think we could go to the next part. Yeah, maybe we can come back to this if there's questions later.
Right. So I'm just going to remove it. Now we are going to ship with 6 different wake words. We actually haven't shown you yet how you can pick a wake word. We'll do that in a bit, I think, Mike, as part of the next demo. But there's, of course, a bigger question here. Open wake word. You wanted to, one of your goals, David, was to really easily enhance it, easily use it. So people are probably asking, can I make my own wake word? And what is the answer, David?
The answer is yes, you absolutely can.
All right. So I'm going to share your screen, and then please tell us what we're seeing.
All right. So this is an example Google Colab notebook. So this link will be, I think, probably in the video notes, and you can also get it on the Open Wake Word repository. Because of the design considerations that I mentioned before, this is synthetic data, right? We generate the data we need to train these wake word models. And so as long as you can generate an example, you can train it. And so we have this example notebook here, end to end. You can run it in about an hour.
David, I'm going to quickly interrupt you.
Yeah.
What a notebook and what is Google Colab?
Sorry. So no, good point, Paulus. So Google Colab is basically just a free computer that Google gives you in the cloud. You can run what's called a Jupyter notebook. It lets you run some Python code. All you need is a Google account, and you can run it for free. So you can use this notebook as is. You can make a copy of it and modify it, whatever you want to do.
Now, we'll point out that for a Google account, you have a certain limit, right? With how much compute. I don't really understand their terminology, but you can apparently pay as you go. If you want to, like $10, you can buy 100 compute units if you run out. But the notebook is taken that into consideration, trying to finish in the amount of time so you don't run out of compute units.
Yeah. So the free compute units you get with when you first open Google Colab should be enough to create your own wake word.
Mm-hmm. Yeah. And the scale of the computer you're getting for free here is pretty modest. So also, if you have a desktop computer or even a reasonably modern laptop, you could certainly train your own models there as well.
Yeah. But then, yes, you can do it on your desktop, but you will need to set up like Python,
Correct.
right? You have to know how steeply increases this Google Colab. Our goal is that anyone can do this. So let's go over the notebook.
Yeah, that's a great point, Paul. So this notebook is designed to be really easy to use. I'm not going to read through all the instructions here. The main point is you want to train a new wake word model. You have a wake word or a phrase in mind. We can see it right here and actually hear an example of what kind of audio clips will Piper, in this case, produce to train the model. So here I have OK Nabu, and Mike already showed that earlier.
OK Nabu.
Hopefully everyone was able to hear that. And that sounds pretty good, but it doesn't have to be that, right? It can be anything that you wanted. So maybe I wanted to do a Star Wars themed wake word. So I can see how it says R2D2.
R2D2.
That was pretty good. And one of the things that we use with Piper is we have variation, right? Natural variation. So when we heard this,
R2D2.
There's a little bit of a pause before that last two. And if we run it again.
R2D2.
sounded a little bit different that time. And that's how we can actually make these models really robust. So you don't have to be robotic. You don't have to very carefully say it the same way. You can say it naturally. The models are designed and they're trained to handle that kind of variation.
And for right now, the Piper model being used, this is English only, but that's not always going to be the case. We as we get more open source data, especially these multi-speaker data sets, and David will talk a bit about that. For different languages, we'll be able to expand this.
So
Yeah.
once you're happy with your pronunciation, so this one is really all, can you get the pronunciation good, right? So sometimes you have to write non-English words to make Piper trick it into pronouncing it correctly. But, like, for example, saying out the numbers, writing out the numbers. But once you do it, once you get it, what's the next step, David?
Yeah, so once you're happy with the pronunciation in this notebook, if you just wanted to go from there, leave everything the same, you could just go to this menu up here and click Run All. That will start the whole rest of the process, take about an hour, and in the end, it will download a model to your computer.
That's it. There's no extra work necessary on the notebook side. After an hour, you can just leave this tab, right? You don't close it, but you don't have to watch it, like, go through all the things. And it will download 2 files, I think.
Mm-hmm.
Yep.
You only need one of them for what we'll talk about here in a moment.
Yeah. So Mike, you want to show us, like, what you do with those files?
Yeah, sure.
You want me to show you your screen?
Yeah, please. Okay, so let me put my sidebar open so you can see where I'm going. So in order to get WakeWord going, you're going to need an add-on, and that add-on is called Open WakeWord. All right, so once you install this, you're good to go. It comes with a number of WakeWords built in, but it also looks in your /share directory on your Home Assistant OS and looking for a directory called Open WakeWord and look for models there. So what you can do to get this is install a second add-on, and we have this in a guide. By the way, there's going to be a guide for custom wake words, so I'm kind of flying through the details here. But if you install the Samba Share add-on and you go set a username password and start that up, this will share it looks like a drive from your Home Assistant. And so let me show you then how you can do this. I'll stop sharing this. Instead, I'm going to share the window. Now I'm on Linux. This will be a little bit different, but the guide does tell you how to do this on Windows and Mac, which are much more common. So here I've got the IP address of my Home Assistant server. Pretend it's blurred out. And
I think for Windows, Home Assistant will just show up as a clickable server, right? So
yeah, if you're on Linux or Mac, it looks you have to enter something more like this, but the guide does actually give you that exact detail.
Yeah.
Anyway, once you're there, all you need to do is pop into the share directory and make that Open WakeWord directory.
Yeah. So you're going to make a new folder called Open WakeWord. This is also in the guide. Yeah.
And then let me go. Sorry, I have in here. So there's a bunch of stuff here. There's 2 things. You need the TF Lite model. So I created a wake word called Open Source. And I've dropped that in there. And then let's pop back to my other screen.
Yeah. And while Mike is preparing his screen, we're showing the add-on of Open WakeWord. There is a Docker image available as well. It takes a command line flag to point it at the custom model folder, but that's all possible. Everything you've seen today, you can achieve with Docker. It's more work.
All right, now back in here, you've put the model in, and the add-on will automatically pick that up. So all you have to do is hop into your voice assistants now and drop down to the bottom. And here we've got a wake word section. So we've had the other sections available for a while. And now here I see I got Open WakeWord, and I should be able to, there we go. So I got Open Source.
All
so
right.
I'll pick that. And now I should be able to hop over here. Let's see if this works now. Open Source, turn on a hanging light.
Boom.
All right. And of course, OK Nabu does not activate it anymore, right?
Right.
So this is how you can switch your wake word. You can create as many pipelines as you want with different wake words.
Yeah.
And do you want me to demo anything else here, Paulus?
Entities. Can you show the entities on ESP Home?
Right. Oh yeah.
Device.
So
What is
uh,
yeah, this one? You can open. Well, this work.
I'll just go through this. All right. Let me drop the sidebar. So there are a number of entities here. There's the use wake word switch that you saw before. This can basically turn it into push to talk or turn it back into a wake word. And then there's an assistant progress sensor that when you've activated it, it should turn on. Open source, turn off hanging light.
Turned off light.
So you can see that turned on and then turned back off. So that's something you could automate off of. And then of course you can pick your pipeline as always. And I think since last time we've also added this Finnish speaking detection. I was actually messing with this last night because I was having my daughter play with the voice assistant. And kids tend to take a little bit longer to think of their voice commands. And by default, this thing will wait just 1 second of silence and then finish the voice command. But you can switch this to relaxed, and this will give it a little bit more time, 2 seconds instead, which for an adult feels a bit too long. Or if you like aggressive, if you're very very punctual with your commands, then you're good.
Well, and the other entity called Assist Pipeline, like Mike just showed when he's editing voice assistants, like your Home Assistant, you can have as many voice assistants as you want, and there's always one voice assistant active per device. So in this ESP Home, currently he has picked his local voice assistant, right? So everything you've seen today has been fully local, running in his house. Now, every voice assistant can also have its own wake word, right? So you could actually change the assist pipeline of an ESP Home device, and you can change the wake word you have to say to activate it. So
yeah, so this could be done through some kind of automation or any other thing. Another thing with this wake word switch, forgot to mention. So we talked about ongoing resources inside Home Assistant, right, to stream audio. Something you can do though, this is ESP Home, right? So you can, the sky's the limit. So if you have something like a presence sensor in your office, let's say, and you have a voice assistant there, what you can do is a simple automation that says, well, if no one's in the office for so long, then just turn off the wake word functionality on the voice assistant, right?
Yeah.
So boom, now you don't have to take any more resources, even if there was, background music hearable through the walls or anything like that. So as always, choice and customizability here.
Yeah. I just saw somebody asking, do you need the latest ESP Home for this? Yes, there's been a beta out today that contains all the latest fixes. It is not necessary to install that if you are just installing it through the browser, because the browser installation file is already running the beta. It's only when you want to customize it, of course.
Mm-hmm.
All right. So I think one thing, David, that we forgot to mention about architecture is that when the wake words that we include with the wake word, open wake word add-on, they are trained way more extensively than, of course, a 1 hour notebook, right? They are like a lot more trained, including negative samples, which I think was very interesting, where like, hey, we're just playing podcasts and we tell the model this is never ever going to be the wake word, so that the model will fine tune also on the negative side.
Yeah, that's a great point, Paula. So the example that we showed previously, where you can train your own model in about an hour, that will actually produce a pretty good model, but it's not the best, right? So that's a relatively small amount of data. You can adjust some settings in the notebook and make it train for longer. But yeah, when we produce a model like OkNabu, for example, we train on a lot more data. We really try to make sure that those false positive, those inadvertent activations are low.
And so there's one of David's goals was having it being able to customize it to a particular speaker. And so this is going to be a future thing, but there is an ability to, if you can record a couple samples of yourself, we're not talking hundreds, we're talking like 3 or 5, through the actual device that you're gonna use. Then you can actually do something called a custom verifier model, which fine tunes it just for that speaker, kind of that environment, that microphone and such. And so this is a trade-off. Instead of training on, training many more hours in the cloud, that you could have a couple samples and have it fine tune exactly. And so that's going to be something we're going to add in the future.
Right. And one question that just comes to my mind is, Does it support speaker identification, so you know who can speak in that case, Mike, if you are recording your own samples?
I'll let David answer this, actually.
Yeah, it's a good question. So I have had some reports from users saying that with the custom verifier model, it can actually kind of serve as a speaker identification system. I don't know how robust that's going to be, but that is a feature we're working on. Yes. So we'd like to get to the point where eventually when a wake word is detected, you also know who said it.
Yeah, I should make it clear, custom verifier models are in Open Wake Word today, but I haven't got them in the add-on yet, so that's on me.
Another person is what happens when two devices pick up the wake word? Mike?
So we made sure we did think of this, and there's a PR that's about to modify this behavior slightly, but basically if two assistants activate at the same time, only one will actually win the day and go forward. And the small PR that I put in recently, it's going to get in the next release, will say that this is only the case if they both have the same wake word, effectively from the same wake word add-on. So if you have OK Nabu on one assistant and OK Nabu on another, and they activate at the same time, only one will win. But if you change the wake word on the other one to, I don't know, Hey Jarvis or whatever, then they can both be activated at the exact same time. Yeah. Now, when I say same time, I mean this is like a 2-second window, so it's a very low probability they both be. But if this means today you can put them next to each other and not worry about it.
So another question. I think this one is also, maybe some people are wondering how much bandwidth is being used by constantly, or not constantly streaming, but like, when we detect voice, we're going to stream audio. How much does it take?
Yeah, so this is streaming 16 kilohertz, 16-bit mono data. This is audio data. So this is about 32,000 bytes per second, which is, not very much given, the huge bandwidths of Wi-Fi. But if you have a lot of assistants, it could start to be a little bit.
Just to translate, this is 32,000 bytes is 32 kilobytes, right?
Yeah, about 32 kilobytes per second. And right now we're not doing any kind of compression because we wanted to make it inclusive for any device, right? Because once you have compression, you might not run on something this small, who knows? But we are looking into that. We could probably get about a 2-to-1 compression savings. But right now, 32 kilobytes per assistant is what you're going to see.
This one is, I think, for you, David. We have more presentation. We have more stuff we want to show, but we're just going to do some Q&A because
sure.
We're excited. Yeah. So, David, are there any requirements for wake words?
This is a great question. So there are technically no requirements. You could use whatever word you want, but this is something to think about, right? If you made your wake word OK, you're going to get activations all the time, both because it's a very small word and also you say that all the time throughout the day. So kind of the recommendation is try to go for 3 to 5 syllables. So OK Nabu has 4, for example, and try to come up with relatively unique words that you think are going to be clear enough to the device to know that you're saying the wake word. So if you're a Star Trek fan, for example, computer is great. I have that as well. That one's a little tricky, right? It's just a common word.
Yeah. All right. So let's see what is next on our creating our own wake words. We just did this. I added in the slide because in the practice we had forgotten this. So. Wake word at launch. So already talked that we have open wake word. We also quickly mentioned that Porcupine V1 is part of a add-on that we are announcing. So there's going to be 32 different wake words at launch. The reason we included Porcupine is because it also works with French, Spanish, and German wake words. You can see the wake words that we support. Computer, Jarvis, Hey Jarvis is there. They words like OK Google, Hey Google, which could be used to make it easier from your household if you're having people that are used to saying older assistants. You can your old assistant, they can easily transition now. Now, of course, for French, Spanish, German, we have things like Stachelschwein. That's just a porcupine in German and porcupine wake word engine, but it's they're just different fruits or these kind of things. So yeah, it's these are at launch, and I think Mike, maybe you want to show how you can choose this. I mean, you already showed, of course, how your custom wake word was chosen, but you didn't actually show Porcupine.
Oh yeah, yeah, I do. I got the screen shared, so
Okay, yeah, let's.
so let me show this is just another add-on that you can install, and there's only some minor configuration options, but really just install it, start it up, and then what you will need to do with Open Wake Word and Porcupine is when you do install it, you'll see it be discovered through the Wyoming integration that we'll talk about in a bit. But you do have to click configure there.
Just to show that.
Say that again.
Do you scroll down?
Okay. So Wyoming's here, and hint, hint. There's other things coming, but you'd have Porcupine and Open Wake Word that get discovered and show up here.
Yeah.
And okay, so then all you need to do is back in your voice assistants. When you scroll down, you could just pick a different wake word system. So here I've got Porcupine version 1, and then I've got my choice here. I'm not going to attempt any of the non-English ones. I'll set it just to, I'm going to set it to Terminator.
All right.
So I do that, and then I should be able to, this is all working still. Terminator, turn on hanging light.
Turned off light.
So I do want to say too, for people that are going to take this to the limits, how many voice assistants can I have streaming, at the same time? You will find a difference in CPU usage between Open Wake Word and Porcupine. Porcupine has a lot less CPU usage, but far less flexible in closed source. So there's trade-offs there. But I was able to get around 15 simultaneous streams going through Porcupine at the same time. However, it did like nearly max out the CPU. So we're telling people expect to be able to do about 5 simultaneous streams and comfortably with a Raspberry Pi 4.
Okay, so these are once again the wake words at launch. Now, I want to quickly talk about the Open Home, right? So, because everything we do around Home Assistant evolves around our vision for the smart home, which is the Open Home. And the Open Home for us is around 3 values: privacy, choice, and sustainability. Now, we've talked about privacy today. We have wake word is local, speech to text can be local, text to speech can be local. Choice, well, we already show you can do a closed source engine, you can do awesome open source engines. There's every part of the stack can be choice. But we haven't talked about sustainability yet. And when we think about sustainability, the thing that comes to mind here is, well, what about like reuse and repurpose? Because anything that can capture audio can become a voice assistant now for Home Assistant, right? So this is a picture of Mike's desk. Mike has basically everything he found in his drawers, he has turned into a voice assistant. And based on that work, we've actually a couple of projects have been born out of that. So to just we're going to go over them. They are all different levels of like skills that you need. So we've also added like a little banner on top of what kind of skill level you need. This one is cool. It's ESP Home, of course. Like we offer you already a browser-based installation, so it's ready to go. If you don't want to do that, you want to build your own. For example, JLO has showed us walkie-talkie in previous chapters. Really cool device. Then you're building your own voice assistant, right? And so we have some recommended parts that we've been testing and that we really like the performance of. I'm not going to try to pronounce it, but you can find those. We're going to be linked in the blog as well. And this is really cool. You can build your own voice assistant. It can look however you want. And to kind of give an example of how cool that can be, I have a small example here from Paul. So let's take a look.
Hello, I will show you my new voice assistant. It's a droid from the Star Wars and Mandalorian universe. It's a R5 droid. It's 3D printed. It runs ESP Home on a ESP32. It has microphone, speaker, and servo motors. And I will show you a small demo. He will respond to his name, which is R5, but I will call him in French because the wake word is configured in French. R5, Turn on living room lights. R5. Turn off living room lights.
Heck yeah.
Awesome.
Yeah. This is really, really freaking cool. So this was 3D printed. It is a paid model that Paul slightly adjusted. We're going to be publishing this on YouTube, this video as well, with a link to the model that was being used, which basically means anyone could print this, build this, right? Like if you have not as much creativity as Paul, like you can make simpler ones. Like I've been personally playing with like buying an old microphone from like the 60s and putting a voice assistant in that to like make it look cool and like to kind of indicate like, hey, we're recording in this room, right? Because that's what you think when you see a microphone. Yeah, so that was the first thing we wanted to show. ESP to build your own voice assistant using ESP Home. Anyone can do that. You could also, and this is another option, is that if you get an Atom Echo Dev Kit, the $13 devices that we showed earlier, you can just start customizing that configuration, right? You don't have to start from scratch. Just start with that board, add some lights, make it more cool. You don't have to start with a whole breadboard, as you can see here.
And within that configuration, you can set the audio enhancement settings. So you can ask for more or less noise suppression, audio amplification from Home Assistant through that.
Yeah.
Right. So this is another a fairly easy one for people. So if your Home Assistant hub or box is not in a closet somewhere, you can turn it into a voice assistant. So you can plug in a USB microphone. So most of them work. Some of them, weirdly, I've had some back and forth with the supervisor, but most of them have worked great for me. And then install this add-on, Assist microphone add-on that I wrote, and this will basically just let you record from there. And it even I like having like little feedback sounds. So when it wakes up, it plays a little beep, and then it beeps to let you know it's done. So that's in there by default. You can turn those off if you don't like them. And so I recommend. It's a little pricey, but this Anker PowerConf S330 is about $79, $80 US, but it's a full-on speakerphone. So like it has all this nice, voice algorithms in there. It cleans up the audio a lot already. And then the speaker sounds great too. So you can plug that in and use that. I did find on a Raspberry Pi 4, I needed to use a powered USB hub because it expects to be plugged into a desktop. But yeah, so turn your Home Assistant box into a voice assistant.
Before we continue to the next one, we have a lot of people watching. Please hit the thumbs up on the YouTube video and like and subscribe. Just so that like more people will be able to see this video because I think this is freaking cool. And so if you like that too and your YouTube, please hit that thumbs up. All right, the next one is the Home Assistant voice satellite.
Yeah, so turn your old Raspberry Pi all the way back to the Raspberry Pi 1 and the Raspberry Pi 0. This will work on, right? Because this is just audio streaming. So there's a Python package here you can install. Basically, give it a token and the address of your Home Assistant, and again, a USB microphone. You could use a speakerphone, or I plugged in an old webcam because I didn't need the audio feedback on that. And so, yeah, you could basically, if you have a Raspberry Pi, a hat, you can get one of those, one of the Respeaker ones, although there's some more complexity. We've marked this as difficulty hard because you need to be able to, flash a Raspberry Pi and install some software on it, which might be out of reach for some people. But okay.
The reason why the add-on is easy is because there's a single button to click to install the add-on, right? Which we'll also be linking in the blog post. One-click install. This is, of course, part of Home Assistant OS, right? Like easy is like the goal. This is, you have to install a Python application.
Something nice about this, and something I forgot to mention in the Assist microphone add-on, both have a very high-quality voice activity detector from a company called Solero. They kindly put out this great model for the public, and what it does is it's very good at detecting non-speech, and so it will avoid streaming in most cases, even with background music. And so you can have that to really lessen the the load on your Home Assistant hub, right? So even on a Raspberry Pi Zero, you could, well, maybe on a maybe on a Zero. I got to double check that. At least on a Raspberry Pi 3, I know you can start using this very easily and not have a big load on your Home Assistant hub.
Yeah, and this is great because if you started your Home Assistant journey back in the days, maybe on a Pi 2, maybe Pi 3, and now you've upgraded to like a Home Assistant Yellow, you know, what is the Pi 2 doing? Is it just sitting in your drawer? Well, now at least there is a use case you can use it for. And so, you know, this doesn't just become e-waste. I see a few questions. I think, Mike, what I want to show you, is this one available as a Docker?
This one, no, I don't have that as a Docker. And the main reason for that is getting audio into Docker through a microphone is a horrible pain. Trust me, the installation process here is much easier, but this could be something we look into in the future with Pulse Audio, for example. It's a little bit easier.
Right. That this is, for example, on Home Assistant OS, we already have Pulse Audio, and we have solved this issue, right, to make sure that audio is accessible to add-ons.
I would love if a community member is able to Dockerize this successfully. That would be an excellent contribution.
So we also have a demo of this one prepared that will actually, it's kind of cool. It compares an ESP32 custom made with a Home Assistant voice satellite running on ESP Home. This is a video by JLO, the creator of the walkie-talkie, but he has many, I think by now he has like 7 voice assistants. So let's take a look.
All right. So these are 2 solutions to run our voice assistant in Home Assistant. On the right, this is a Raspberry Pi 3, an old Raspberry Pi 3 with a combo mic and speaker. This is actually the first Raspberry Pi that I used when I started Home Assistant. And on the left, this is an ESP board with a small mic, a small DAC, and a small speaker. I have it here just to show you. So the small ESP32 board, a small DAC linked to a small speaker, and a small microphone on this side. I will actually display the component name that I used for this one on the screen right now. So if you look at the pipeline for both of these voice assistants, everything is in English for both, except for the wake word that is still in French because it's a bit simpler for me to trigger. On the Raspberry Pi side, the wake word is raspberry, but in French. And on the ESP side, the wake word is sunflower, but also in French. In terms of feedback, this one will make a small noise when the wake word is triggered. And this one will use the small LED that is on the board. All right, so let's start the demo. Framboise, turn on the kitchen lights.
Turned on lights.
That was the Raspberry Pi solution. Tournesol, turn on the living room lights. The ESP solution. Framboise, open the shades.
Opened.
Tournesol, turn on the entry lights. Framboise, turn off the living room lights.
Turned off lights.
And that's as far I can go. That's pretty cool.
Yeah, so this is really, really sweet, right? You can see 2 voice assistants at work simultaneously, both having the audio sent to Home Assistant, both processing different wake words such that they can just coexist. What is really cool here is that you could actually have 2 wake words for 2 different languages, right? So where if you're a user with Google, they support like, oh, you can either speak either language, it will figure it out as you speak. For us, it's going to be, we're going to just do this on a wake word basis. So you can have a English wake word and a German wake word. And so, when you speak the German wake word, you're going to speak German, you get a German response, and the same thing for English.
I think I saw a question. Someone asked, what about a respeaker? Probably referring to like the respeaker Pi hats, maybe. those still work through. There's someone forked the repo and has fixed the drivers. I'll have to put a guide together for that and point people there so you could buy that person a coffee or something.
Yeah, that's a very cool project. I'm glad somebody is picking that up again. Here, I know Blackadder is asking, what about the new S3 box? Now, the thing with ESP32 S3 box right now is that we have configuration available for the normal one and the light. We do not have a configuration yet for the 3, which will is something that like we're playing with as well. The reason we haven't looked at it today is they're out of stock. So the old S3 box and the S3 box Lite have been discontinued. The S3 box 3 is new. They announced it. They released a very small amount, but it was completely sold out right away. We've talked to Espressif. It's coming in stock, and we will definitely target it because it has 2 microphones and more horsepower to do audio processing. So it's something that is on our radar. Not going to give you a lot of better performance today, but definitely in the future. Let's go back to the slides. So besides the different parts that we just showed you how to create wake words, we also are opening voice office hours. And we are opening voice office hours not for users to help create voice assistants, but we were opening office hours to help scientists and engineers that are creating wake word, speech-to-text, or text-to-speech engines to make them compatible with Home Assistant. If you are working on such technology, it is a great benefit to make it compatible with Home Assistant, because a voice assistant is many different parts of the stack. If you can have your technology test out among a mature stack that people use, it makes it easy to get a lot of people to try real world usage of it. It helps get feedback, and so it's very beneficial. There are 2 different ways of including your wake word speech-to-text or text-to-speech model. Our favorite one is Wyoming. This is how actually all of the things that you've seen today basically work. Wyoming allows Home Assistant to outsource it to a application that runs either inside Home Assistant as an add-on or on another server. So even though you saw today, Mike was saying, you can run 5 open wake words on a Raspberry Pi 4. If you have a supercomputer in your house, or maybe just an Intel i7 or something, you can run a lot more wake words. You can just load the model there and let Point Home Assistant at it. But this is also for scientists a great and easy way to get their model included in Home Assistant. So if you are working on an engine, please reach out to us. We would love to connect and help you get your stuff integrated in Home Assistant and get it shared with the community. I think a lot of people will love it.
And really increase that choice, right? So that everybody has a choice of something that works just right for them.
Yeah. Now that we have the 4 kind of pillars for voice in place in Home Assistant, wake word, speech-to-text, conversation, and text-to-speech, we also feel more comfortable to talk about our goals. So I think the main goal for us is feature parity, right? We want to get more voice commands. We want to make sure that people that come from either a Google or an Amazon ecosystem, that they are able to say the things they want to say. So obviously control your house, very important, but also things like timers. We need to get timers. If we don't have timers, then people are going to run 2 voice assistants or 3 or whatever, right? Multiple shopping lists. We added shopping lists 2 releases ago, I think. I think. A lot of requests came in for multiple shopping lists. That's something somebody's working on. Also, weather definitely has to, being able to ask what the weather is going to be today. We should get that going.
Now, we didn't demo it in this chapter because we demoed it previously, but some people may be unaware that there is a sentence trigger in Home Assistant that's been there for a couple of releases. So in an automation, you can say, when I say this sentence, do this. So if there's a particular niche thing that you have that isn't supported yet, you can add it today very easily.
The other thing is we already mentioned it, audio wake word. So let me stepping ahead. Wake word detection. We are going to see if we can get wake word detection going in ESP Home, mainly focused on the ESP32S3. Probably if we get there, it would be a new open source model that probably wouldn't be as customizable as Open WakeWord. So not sure if this has as much appeal as like the full freedom that Open WakeWord gives, but it could be using less resources on Home Assistant. So it's definitely something we are willing to explore, but we also could definitely need some help. So if you're like an audio AI model expert, please also reach out to us, Voice in Nabukasa, and let's see if we can figure something out. Other part is also audio processing in ESP Home. Now we do a bunch of processing inside Home Assistant, noise cancellation, gain improvement, volume multiplier. And there are some stuff that you can actually do on a device if you have two microphones, and Espressif has released like an audio development framework that they target at the ESP32S3 box 3. So if we are able to get that going, then it would actually improve the quality for audio capture, both for wake word detection and for speech to text, right? So both will be improved. So that is definitely things we're looking into. And of course, we haven't even put it here, but the open wake word fine tuning is also something that we definitely want to add.
Yeah, definitely.
That's a wrap for today. So a big thank you. Obviously, David, he's the hero of today. Open wake word is amazing, and I hope that we can see many custom wake words. Also, I mean, to the community, if you are building custom wake words, please share them. We're going to open a category on a forum, so it will be easy for people to share wake words. They're very easy to drop in. Because, if 100 people are going to all compute the same wake word, like, it's way easier to share. It's, like, a lot more sustainable to do so. So let's, group our power and get that sharing going. Then, of course, I also want to just shout out Jesse Hills, lead of the Home. He's been very patient while Mike and I are just wandering around, trying different architectures, and he's kind of helping us out there. And of course, all the people at Nabukasa for helping make content, create the guides,
and testing. They've done so much,
and all the core technology. And all the language leaders. These are the people that are helping the sentences that Home Assistant supports. So if you're missing an intent, missing a sentence, you feel like Home Assistant should support, you can test it out in the developer tools nowadays. There's an assist developer tool. You should, talk to these language leaders, help, if a sentence is missing, and maybe they can help you get it included into Home Assistant. And lastly, if you want to support the work, you want to support us building more cool stuff, please subscribe to Home Assistant Cloud by Nabukasa. It really helps us because it pays our bills. So at least we can bring our full attention and focus on building cool stuff. And that's a full-on wrap.
And there will be more.
I'll see everybody in Chapter 5. The blog post will go live. The YouTube, all the videos we've shown today. Before we go, I will one more time show Paul's video with his kick-ass droid, because and then I wish everybody a good day and happy building.
Hello, I will show you my new voice assistant. It's a droid from the Star Wars and Mandalorian universe. It's a R5 droid. It's 3D printed. It runs ESP Home on a ESP32. It has microphone, speaker, and servo motors. And I will show you a small demo. He will respond to his name, which is R5, but I will call him in French because the wake word is configured in French. R5, turn on living room lights. R5, turn off living room lights.